this example, we're going to determine whether the function is even, odd, or neither. Then describe the symmetry. G of s is equal to 4s to the 2/3. First, let's recall that for an even function, f of negative x is equal to f of x, and the even function is symmetric about the y-axis. And for an odd function, f of negative x is equal to negative f of x, and the function is symmetric about the origin. G of s is equal to 4s to the 2/3. We're going to look for g of negative s, which is equal to 4 times, between parentheses, negative s to the 2/3. To show that this is even, we're going to transform negative s to the 2/3, the fractional exponent, into a radical. So it's going to be cube root of negative s to the second, negative s squared, or negative s squared is equal to negative s times negative s, which is equal to s squared. Therefore, negative s to the 2/3 is equal to cube root of s squared, which is equal to s to the 2/3. Now we're going to go back to g of negative s, and we are going to replace negative s between parentheses to the 2/3 by s to the 2/3. We realize that g of negative s is equal to g of s, the original function. Therefore, g of s is an even function. G of s is an even function, and if a function is even, then the function is symmetric about the y-axis. Therefore, g of s is symmetric about the y-axis. We can see it with the graphing calculator. When we graph g of s, we realize that it reflects over the y-axis, right? And we can zoom in to see that the two branches of the function are a reflection over the y-axis.